All right, this is page 2 of the Unit 3 packet. So this is looking at periodic table families. We already defined families on the previous page as being a vertical column, an up and down section of the periodic table. So if I just draw, this is a terrible drawing, draw my periodic table, I drew the left section way too wide. Here's a periodic table. So this right here, I need to wipe this out a little, I think. This right here would be group number 1 on the left. This is group number 2 right here. This is 3. This is where the D block starts, and this is 3, 4, 5, 6, 7, and it goes all the way across until 12. So this is 3 to 12, the D block. And then we have 13, 14, 15, 16, I ran out of space again, 17, and then 18 is at the very far right. 17, and then 18. So 18 different groups or families that are across the top that we number them. There are a couple of groups that we're going to pull out, and we're going to identify them by name, and we're going to talk about some of their properties. So group 1 is this column right here. And I'm going to go ahead and kind of color code these as we go. So group 1 is this column here. This is called the alkali metal family. And the alkali metals, they are all metals, so all the properties we talked about on page 1 for metals are still true. But in terms of comparing them to other metals, the alkali metals are the most reactive metals. We said last unit that everything in group 1 becomes a charge of +1 when it becomes an ion. So all of these elements just have to change by 1 electron to become like a noble gas, and that makes them really reactive. They're trying to figure out how to lose that 1 electron. Because they're so reactive, they're never found in nature as pure elements because they react, and they react to form a compound instead. So they're never found just isolated and all by themselves because they're always reacting. Okay. In terms of their densities, these are going to have relatively low densities overall. So that means that their mass compared to their size is pretty low. And they react violently with water. So if they are placed in water, they catch on fire and they can explode and get really fiery. Examples from this family, just looking at the periodic table, would be lithium and sodium, for example. And on here, actually, let me make sure I put a note on here. Hydrogen is actually not a metal, so hydrogen is not in the alkali metal family. I'm just going to put no family for hydrogen. It's kind of all off on its own. Our next family is group 2, which is called the alkaline earth metals. And so the alkaline earth metals are in group 2, that second column. So if I pick a different color for that. So alkaline earth metals, when we compare them with alkali metals, they are going to have some properties that are similar because they're still metals, but they're not going to be exactly the same as alkali metals. And so if we look on here, they are pretty reactive, but they're definitely less reactive than group 1. So let's say fairly reactive. So they definitely like to react still, but not as much as group 1 does. They're usually found in nature as compounds. That's a small line. Not as pure elements. Not always going to be the case, but kind of a general thing again. And they are going to have higher melting points and density than group 1. So for some examples from group 2, calcium, magnesium would be examples of those. For these charges as an ion, in the first column, these want to lose 1 electron, so they're going to have a charge of 1. And when we say lose, you would think that would be a charge of negative. It's actually going to be positive because remember, electrons are negatively charged, so if you lose negativity, you're more positive. For group 2, these elements are going to change by 2 electrons to become a noble gas, and they are losing 2 electrons, so they're +2. Group 3 through 12, that is the entire D block. So that's this whole middle section on the periodic table. So we group this entire thing into one family, even though it's actually 10 different individual columns. We group them together. We call them transition metals. And so for these transition metals, this is, again, the D block elements. They are going to be less reactive than group 1 or group 2. So these metals can still react, but these are going to be formed or left as pure compounds or pure elements instead of forming compounds much more often than group 1 and group 2. So some of the elements in this category that you've heard of would be silver, gold, iron, zinc, titanium. So there's a lot of elements in this section that you've probably heard of. Something like silver and gold, it's important that they're not reacting like crazy because you don't want your silver and gold to just be tarnishing really quickly over time. So if you have something made out of pure silver or pure gold, you might need to actually kind of clean the outside surface of it to get rid of the buildup from it reacting on the outside, but it's not reacting super fast. You can wash your hands with a silver or gold ring on and not have it explode. So they're definitely less reactive than group 1 and group 2 metals. One thing that's different about the transition metals, they can form more than one charge when they form an ion. And so the periodic table does not allow us to predict the charge of these elements. We were able to predict the charge of the elements in the S block and the P block based on the number of valence electrons, but the transition metals are kind of weird because their d electrons are strange and we don't really know what to do with them for predictions. So I'm just going to put varies. Different elements in the transition metal chunk have different charges, and you have to be told the charge. You can't just look at the periodic table and predict it. Okay. We're going to skip groups 13 through 16. You can look up, they do have different names, but these families just don't have as much in common because we start to have a mix of metals, nonmetals, and metalloids in a single family, and that's not super helpful for classifying properties. When we jump over to group 17, so that's the second from the right now. These are called the halogens. And for the halogens, these are our most reactive groups of nonmetals. So the alkali metals were the most reactive metals. The halogens are the most reactive nonmetals. The reason for that is when we get over here, these elements are only one away from being like group 18, which is the goal. And so they only need to change by 1 when they form an ion. They need to gain 1 electron to move over to the right. And when you gain an electron, you become a charge of -1. Essentially, elements that are going to be +1 or -1 for their charge are the most reactive elements. Examples here, looking at my periodic table, would just be fluorine, chlorine, bromine, iodine. You can pick anything from that list. Group 18 is our far right. I'm trying to pick a color I haven't used. So that far right column, we talked about this last unit. And those are called noble gases. So for those noble gases, they are colorless. So you don't see any color to them. They are odorless. You don't smell them. They are tasteless. Taste has any tasteless gases. So these are things that you wouldn't really recognize if you were exposed to them. The most common example that you guys have probably seen before is helium. So helium balloons are filled up with a noble gas. They're gases, you don't see them. If you pop a balloon, you don't see a color come out. You don't smell a specific odor for them. And the most important thing about noble gases is that they do not react at all with other elements. So they just kind of float around and do their own thing. And that is why their charge, when they make an ion, they don't make ions, right? They don't react. They have the magic number of 8 electrons already, so they don't form ions. They don't make a charge. Their charge is just 0 all the time. Couple things just to tack on here. We already kind of said this at the top. Hydrogen doesn't fit in with the other families. Hydrogen is a unique element, so it doesn't really have a family to fit in with. It exhibits unique behavior because it only is 1 proton and 1 electron. It is a gas at room temperature, and it can react with many different elements. When bonding, it can form a charge of +1, so in that way, it kind of behaves like an alkali metal. But it can also form a charge of -1 if it's making a bond with a metal, which is kind of like a halogen. So it doesn't really belong in the alkali metals category. It's not a metal, it's not a solid, it's not a good conductor. Doesn't really belong with the halogen because it is +1 for its charge sometimes, which is kind of more like an alkali metal. So it doesn't really exactly fit, and we don't put it in any family. One last chunk on the periodic table is the inner transition metals, and these are the F block elements. So the transition metal are the D block. So this is the transition metals. The section that belongs inside the transition metals at the bottom, the F block, is called inner transition metals. It's just kind of a name for that chunk. The lanthanides are all called rare earth metals. They're pretty rare in nature. And the actinides are all unstable and radioactive. So just a little bit of information about the F block. We don't really talk about it or use it all that much. Okay. There's a note on here about phases. So what phase different elements are in at room temperature. So most are solids. There's a couple that are liquids. And that's actually only 2 elements on the whole periodic table, which is mercury and bromine. So on here, I'm just going to kind of color code those 2. I'm going to use blue. So those 2 are going to be, what am I looking for? Mercury and bromine. So those are 2 that are liquids at room temperature. And then there's a handful of elements that are gases at room temperature. The elements that are gases at room temperature, first and foremost, are going to be all of our noble gases. That's why they're called noble gases, because they're all gases. So all of group 18 are gases. And then a couple of other elements are gases as well. That's hydrogen. And then over here, nitrogen, oxygen, and fluorine. Chlorine. So those are our main elements that are going to be gases at room temperature. So we just kind of have a handful of them there. And then most of the other elements that we didn't shade in are going to be solids at room temperature. And the periodic table that we have in our classroom actually has these color-coded as well in the font that the element symbols are written in. If they're written in black, then they're solids. If they're written in blue, then they're liquids. And if they're written in red, then they're gases. So again, that's kind of just a way that periodic tables that are printed in color can try to show you the different phases on the periodic table themselves.